Page 12, number 1, asks for the algebraic property that justifies this statement. 5 plus 7 is equal to 12, therefore 12 is equal to 5 plus 7. That is a true statement, but why is it true? What's the connection between these two equations? The left and right sides have been switched. That's the symmetric property. Number 2, if 4 times 2 is equal to 8 and 8 plus 3 is equal to 11, then we could write 4 times 2 plus 3 is equal to 11. Why can you do that? What's the connection of this statement to the previous ones? The number 8 has been replaced with 4 times 2. That's the substitution property. Number 3, 3 plus 5 is equal to 8 and 8 plus 1 is equal to 9. So we could write that 3 plus 5 plus 1 is equal to 9. What is the relationship of this statement to the previous ones? The number 8 has been replaced with the 3 plus 5. That's the substitution property again. Number 4, r plus s equals r plus s. Which algebra property says that any expression is equal to that same expression? That's the reflexive property. Number 5, the real number 3 plus the real number 1/2 is a real number. That's the closure property for addition. The closure property says if you add real numbers, you will get a real number. Number 6, 10 times negative 5 is a real number. This is the closure property for multiplication. A real number multiplied by a real number will create a real number. Number 7, negative 9 plus 0 is equal to 0 plus negative 9. What is the connection between these two expressions? They are the same two numbers added together, but the order of the numbers has been switched. That is the commutative property. Number 8, 3/4 times 5 plus 8 is equal to the 5 plus 8 times the 3/4. That is again the commutative property. The only thing different is that the order of the things has been switched. The next questions ask us to identify if this set is closed or not closed, under addition or under multiplication. A set of elements is closed under addition if when you add those elements, you get a number that's in the set. So if you add 0 to itself, because that's the only thing in the set, do you get a number that is in the set? Yes, you do. This is closed under addition. 0 times 0 makes a number that's in the set, so that is closed under multiplication. Number 3, what about the set containing 0 and 2? When you add numbers in the set, do you get an answer that is in the set? When you add 0 plus 2, you do get 2. But if you add 2 plus 2, you get 4, which is not in the set. So number 3 is not closed under addition. Question B, are 0 and 2 closed under multiplication? 0 times 0 does make a number in the set. 0 times 2 makes 0, which is in the set. But 2 times 2 makes 4, which is not in the set. This is not closed. Number 5, is the set of natural numbers closed under addition? If you add together any natural numbers, do you get a natural number? 1 plus 1 makes 2, which is a natural number. Another example would be like 1 plus 10, which makes 11, which is a natural number. Or 3 plus 6, which makes 9, which is a natural number. So this is closed. If you multiply natural numbers, do you get a natural number? 1 times 1 does make a natural number. 3 times 6 does make a natural number. So this is closed. Number 6, is the set of integers closed under addition? If you add integers, will you get an integer? Negative 2 adds 0 makes negative 2, which is an integer. Or 0 plus 1 makes 1, which is an integer. This is closed under addition. What about under multiplication? If you multiply integers, will you always get an integer? For example, negative 7 times 1, that does make an integer. Or negative 3 times negative 2, that makes 6, which is an integer. This is closed. Number 9, the squares of the integers. If you add them, will you always get a square of an integer? One perfect square is the number 1. Another perfect square is 4. If you add them, however, you get 5, which is not a square of an integer. So this is not closed. If you multiply the perfect squares, will you get a square of an integer? One perfect square is the number 9. Another perfect square is the number 4. When you multiply, you get 36, which is the square of an integer. 36 is 6 squared. Let's try another example. 16 is the square of an integer. 100 is the square of an integer. When you multiply, you get 1,600, which is also a perfect square. 40 times 40 is 1,600. So this answer is closed. Number 11. Find 3 star 2 if we're told the star symbol means to take the first number and add one more than the second number. The first number is 3, so we're letting the letter R be 3. The second number is 2, that's the letter S. Following this instruction, we could find R star S by taking the 3 and adding 2 plus 1. That makes 6. Is the set of natural numbers closed under that operation represented by the star symbol? If you take any two natural numbers and you follow this rule, are you guaranteed to get a natural number? Yes, you do, and so this is closed. Is R star S commutative? If you change the order of the numbers, will you get the same answer? Let's try an example. We already figured out that 3 star 2 made 6. Does 2 star 3 also make 6? Let's follow the rule. This is R, this is S. So we have 2 plus 3 plus 1. Notice that that does make 6. We could try other examples, but we would find out that this is commutative. Is the star operation associative? For an operation to be associative, there first have to be 3 members. We might call them R star S star T. Associative also involves grouping. An operation is associative if when you group the first 2 together, you get the same result as if you had grouped the next 2 together. Let's try one example and see what happens. What is 3 star 2 star 5 if we group the first 2 together? This becomes 3 plus 2 plus 1, which makes 6, and then we can take that result of 6 and go 6 star 5. This makes 6 plus 5 plus 1, which is 12. Now down here in this space, let's figure out what 3 star 2 star 5 is if we group these 2 together. Will it also turn out to be 12? The order of operations says to figure out what's in the parentheses first. So we're going to first evaluate this piece. This is 2 plus 5 plus 1, which makes 8. Then we'll figure out 3 star 8. This is 3 plus, parenthesis, 8 plus 1, which is 12. We get 12 both times. So the star operation does appear to be associative. We will answer question C, yes. For the review assignment, we're asked to graph the set of numbers k such that k is an integer and it's between -3 and +7. So let's find those numbers. Here's -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. We're not going to do shading because we're looking for integers only, so we will have dots. Our first dot is at -3 because the k can be equal to the -3. When we look at the 7, we also have the or equal to symbol, so there's a dot at 7. And then we want to put dots for all integers in between those. Number 12, let's graph the set of numbers w such that w is an integer and it's between 2 and 5. Here's 2, 3, 4, and 5. We don't want a dot on 2 because it doesn't have the equal to 2 symbol. We can have a dot on 3, and on 4, and on 5. For page 8, number 10, we're asked to list out the elements. So let's list everything that works for set S if S is a subset of this set. One subset of that is the set containing only the element -1. Another possible subset contains the 1. Another subset would be to select both of the numbers. And the empty set is a subset of all sets. Number 12, let's list the elements that work for Y if we're told that Y is the empty set. That means there are no elements that work. So we could write empty set. And last, number 14, write down all sets N such that N is a subset of this set. So let's look at this description. Y is an integer and it solves this equation. That means Y has to be 7. So one subset is the set containing the solution of 7. Another subset would be the empty set, because the empty set is a subset of all sets.